Okay, so let's share the progress. So we missed a few people. Here I've seen, I can show that the demo, I almost prepared, so I spent a little bit more than I expected. So with all this Parquet and Java, C++ and interop. So let me start, but yeah, I will publish it. Okay, so that's gonna be the playground with ability to switch different databases. I implemented very simple macro system. I can increase the screen. And for now, it can work with the Postgres. So you see that this macro is expanded into the Postgres stuff. And it can work with the DuckDB. I spent like a day to make it work with GDBC. So, and you see, this is DuckDB specific. I only implemented few like $, which means the pass expression. It's a small subset of JSON pass, just indexes and field names. I implemented age in years, and I also implemented unnesting because for Postgres it unnest, let's say unnest name, and we know this. Yeah, so it works. Here we see in DuckDB it's just unnest, but for Postgres it's gonna be like JSONB array elements. So I'm gonna add the history of queries and run this demo on a public, so everybody will be able to try. So for now, the same files which I shared behind, they are loaded into Postgres and they loaded into DuckDB. Okay, the macro is quite simple. So just a few lines of closure code. Maybe it looks a little bit cryptic, but it's quite easy to implement in any language, I think. And I just implemented it with multi-methods for Postgres and for the DuckDB. Okay, that's everything from my side for today.
Oh, that's super slick.
Yeah, I play it like almost like 3 days with the Parquet schema generation and direct JSON to Parquet export instead of going through Avro. That said that we don't have Avro guys because I have a question why they usually go through Avro, not directly writing to the Parquet file and using Parquet schema. So,
what did you learn in that process? Like, I've never tried generating one of these schemas in Parquet directly.
It's quite simple, to be honest, if you get to the right Java classes. Yeah, but that took a lot of time to reverse engineering and analyzing bunch of code like from Hadoop and other Spark stuff to understand that it is really simple. So the Parquet writer is simple, the schema is quite simple. So I think we potentially can generate the schema directly from structure definitions. So, and that's the next topic. I'm still curious about the map data type because it's opened some possibilities, like having not fixed column names, but maps. And for example, extensions can be done this way. So we can say soft extension is a map with arbitrary keys. But I'm still curious how it works internally. So I will try and share. Yeah. And because I stuck with this, I didn't publish this transformation, but I will. It's going to be a small closure project, how I do transform the JSON to SQL on FHIR JSON. But it's quite simple.
I am slightly concerned that we're inventing a new dialect of SQL.
It is not new dialect. Just for now, it's just a few very simple macros.
Right, but I have to write a macro language, then I have to run it through some transform in a stack I know nothing about. Suppose there are only implementations that do transformation completely in, let's say, closure. Now I have to figure out how to run a closure script before I can run my SQL. If I want to integrate that into a end-to-end system that becomes a component, right? So now I need a JVM. You see where this is going? We're inventing something on top of SQL. I can't just write queries and expect it to work. I have to write meta queries, so I have to learn a new
You can
dialect.
write queries in dialect. So in this demo, if you choose the database, you can use the specific dialect.
But then it's not interoperable.
Yeah, then it's not interoperable. Yeah,
that's a problem.
Yeah,
well,
so maybe I have.
Sorry,
Josh, please go ahead.
I'm just trying to figure out kind of sort of goals and impressions here. Evan, your observations make me think that there's a different approach, that you're kind of a different direction you're wishing we were heading in. Can you say a little bit more about, you know, what that would be?
Well, customers who are trying to use FHIR data in our traditional RDBMS stores are not going to be impressed by the fact that they have to write their SQL this way in order to be able to then translate their queries into their databases of choice. And companies who want to build products based on this foundation are not going to be impressed by the fact that if they decide to write SQL, ANSI or otherwise, or, you know, they write it because in their test platform, they're using, I don't know, Postgres, for example. So they write a bunch of queries for Postgres. They create Power BI reports about it. They want to sell these and they want to say, oh yeah, as long as you're using a SQL on FHIR compatible schema, you can just, you know, plug and play this stuff. Well, that won't be true, right? Because you'll have to write everything in this weird meta SQL language so that then it can be translated into the target database of choice. And I feel like we're going way out of scope of what we're trying to do here. We are trying to make FHIR work on SQL. We're not trying to invent an interoperable SQL language that works on every database platform. That's a different project.
So
a worthy project, but a different one.
Can you say a little bit more about what that, you know, should mean for a direction? Like I'm having trouble inferring from your comment what you wish we were doing instead.
I think what I want to see is the ability for people to actually write SQL and have it work. So if we are inventing a schema that we expect everyone to use that requires certain features that mainline databases don't support, such that you have to write the syntax differently, then I think we're missing the mark, right? This is one of the biggest complaints about SQL as it is today, with, you know, Oracle having certain quirks, ANSI SQL being slightly different than T-SQL, MySQL having different create table syntax. Like, these are problems in the SQL world. And I think that if we try to create a schema that can't be simply expressed with common SQL that will work on all of them, then we're not making the problem any better.
Mm-hmm.
We're not solving anything. We're just...
Yeah. So let me comment. So we tried to do both. So initially, because the modern databases support nested data structures, so and we have kind of data in FHIR format. So that was expected to be the first step, like to investigate that we can load the FHIR in JSON into such databases, like DuckDB, Parquet, Postgres, and other stuff, Oracle. But after that, as we discussed, so there may be the flattening layer, which may be expressed with a SQL, like DBT do. So you can flatten your data with a SQL and describe your views and materialize this. And that could be the second step. So when we flatten the data, so then it could be just like more standard SQL to work with this deduced schemas. The problem that we could not express FHIR one-to-one with the flattened tables, it won't work. But I expect that we can build kind of useful flattened tables, which should be distributed like profiles, like views, like flattened views.
So
then can be generated directly from data if it's not FHIR, for example, or using this SQL on FHIR JSON nested data structures through the queries, like ELT guys trying to do. So that's the idea.
Did you look at what Microsoft did with their Synapse SQL schema?
No.
They seem to have flattened all FHIR into standard relational database tables. And they have a whole set of SQL files that do this, that create all of the schemas for every resource in FHIR. I've also seen one with Google Protobuf that does the same thing. So I'm questioning whether this premise that we must have these
why do you think
SQL
that
structures that will require exotic SQL and transformations is truly necessary.
Are you sure about Protobuf?
Not 100% sure.
Yeah, because the Protobuf is the same like Parquet. So this is like a Dremel. This is idea that you can represent the nested data in BigQuery, and guys just translate it like I did to Parquet. They translated to the Protobuf, and it is a nested data structure. And so I'm going to add the BigQuery to this and see how it works. But I expected almost the same like Spark SQL or DuckDB, so the same features. The problem that there is no way from my side so that we can flatten FHIR. Otherwise, you get the thousands of tables, and it will not work efficiently. And we have this Dremel paper, and that the nested data structure may work on columnar databases. We have binary JSON in Postgres, and that could be the good start. Like you can load FHIR without losing any information into these databases, then build flatten representations of it. Do you think it's still the wrong direction?
I'm just concerned that no one will use it. I can tell you right away that if anyone saw this meta stuff in like a sales meeting, they just say, what are you talking about? This is crazy. They want to be able to use standard SQL tooling for FHIR analytics.
Yeah,
and I don't see how this is going to get us there.
Yeah, they will be able to do this on flattened views. So when you can define on top of this like a FHIR representation lossless, that set of flattened views, they can be standardized, they can be published as, I don't know, view set by ONC or view set by CMS. So then they can be supplied with a SQL on FHIR, which can translate nested data to the flatten. And then the set of rules can be expressed on top of these views.
So can we constrain the use of this meta stuff then in the creation of views?
I think the views will be published like profiles, yes. So they are not gonna be one-to-one. They're not gonna keep the whole FHIR information. So you may simplify this views, lose some information, throw away some extensions and other stuff, but they will serve to specific use cases.
Yeah.
They can be described with this SQL on FHIR syntax, but from other side, people can translate it through the different pipelines, just getting the same flattened representation through the different way.
I only think that the problem we're going to run into, which you're trying to solve here with the meta language of being able to describe these nice, neat, rectangular SQL-friendly views, they're going to have to be database specific, right? Because the syntax for Duck and the syntax for Postgres is different. So I could definitely see that this meta language will be required to be able to create platform specific view declarations. But I want to be careful that that the guidance that we're going to be giving on this is not to write actual queries using this language.
Yeah, but this is kind of simple stuff. It's just a very simple macro language, and I would like to keep it
simple to you.
Very small.
It is my point.
Yeah, in the worst case, you just have to write the platform specific SQL for the specific database. Yes, you can switch and like in DBT just say, okay, I'm doing this for Postgres, or I'm doing this for BigQuery. I'm going to.
I don't like that at all. See, that's the part that really bothers me, because my whole interest in this project is to create something where queries are cross-compatible across these different platforms.
So from this
Evan-
point of view, you can start defining your flattened views and try to
Right.
express your rules on top of these flattened views. And how these views will be filled, it's another question. So they may be filled through this macro language,
Yeah.
through the binary JSON or something else, or they can be filled directly from legacy.
I feel like we'll probably have a more productive discussion if we're comparing proposals rather than critiques.
Yeah.
Evan, it sounds like you have an idea about like what you want this project to do. Maybe next week, could you bring to the table like sort of a sketch of what that looks like, some examples, so we're sure that we're on the same page about kind of what you have in mind for the scope?
We've been talking about for the last several weeks this concept that we'll have use case specific views. And I think that's still the direction we're going. My concern is the proliferation of database platform specific querying. I would like to not have that, right? That's the antithesis of interoperability.
But if you want to not have something, like, can you bring a positive view to the table? Maybe next week, bring a proposal for what you do want us to have.
I want to have what we've already discussed. What I'm afraid is that the introduction of this meta syntax into, I don't want people to start using it to write queries, right? I don't know if that's the best idea.
But do you want?
But then
people
again,
to
I
be
can
able to-
also say that it wouldn't be if you were willing to actually do the transform first. So maybe it's okay.
In each of the databases, they kind of invented their own JSON
Yeah.
syntax for that same thing. And we
Yeah,
can
they
say, we can use the native one for each one, but you still need that translation layer. If you want to talk to Microsoft SQL, there it uses the JSON path structure. If you want to talk to PostgreJSON, you use the arrow double caret structure. You know, those things aren't in standard SQL. So I don't know that we can get to something that will be directly executable across all of them, because we're using features that they've done custom work for.
And that's what I'm trying to get at, right? I would like to have a way to map all of these various database specific syntaxes into something that is NC-SQL queryable, you know? And that might be just one of these view use cases. That's fine. That could be the way we position this.
Yeah,
Right.
but yeah, if you're talking about NC-SQL, so the last version of NC-SQL includes JSON path.
Right.
So then, okay, so you may wait until all databases supported. So that's what for the JSON databases. Yeah, the last SQL
Right.
included JSON data type and JSON path expressions. So the
Right.
databases are kind of late to support it. So I think the Postgres is most advanced. Some pieces supported in Oracle, some very simple stuff in MySQL and Microsoft. But at least the basic stuff like accessing elements working everywhere with the small differences. That was a
Right.
general idea for this simple macro,
Mhm.
which still provide us ability to write the interoperable query without losing a lot. And as well, it worked with the columnar databases, which is nice. So, but I think it's better to go through the real example.
Okay.
Because I see you scared this syntax, but it's really simple.
You know,
So, yeah.
You're starting to convince me. So if I think back, if I take a step back and I think about what I'm working on, my main interest, the main use case I want to satisfy here is to be able to run clinical quality language queries on SQL. Even CQL has an intermediary form and requires translation. So I could buy into a meta query being a feature of this project.
Yeah.
As long as there are fairly robust reference implementations that we also provide. If we do that, then I think it'd probably be okay. Especially if, you know, like a JVM reference implementation, I think would solve like 90% of the problems, right?
Yeah, I even
has
think
JVM
that we
ability,
should
right?
provide the solid semantic of it. So let's say the accessing elements by indexes and the field names looks quite solid, yes. So, and using for that very simple path expression like dots and wires for indexes, that looks solid, yes. And that what's supported by most of databases somehow. So unnesting, so when I analyzed, most of databases provide this way to do the unnesting. So it may be another, some datetime functions like ages and stuff like this, and
Yeah.
maybe like array contains functions. Yeah, so we
Should
can,
we be using
have a
FHIR for
matrix.
this?
Yeah, we can have a matrix, we can have a table of examples and some reference implementation. It could be even in JavaScript. So my intention was initially to write the reference implementation in JavaScript. So I'm doing enclosure like for prototyping because I can do it much quicker. But after that, I'm going to implement it in JavaScript or maybe somebody else. So to keep the algorithm simple.
So I guess my question is, should we be using FHIR for this?
I'm scared a little bit the FHIR because it has a lot of features, which is the translation of these features may be the problematic.
Yes.
So if you can
I
bring
agree.
to the table some basic features from SQL or FHIR which you want to be supported, so we can kind of go through the databases and see, I don't know, these datetime functions are supported or not, some other cases, and select some very small subset of FHIR and SQL functions, and try to implement it for different databases.
Worried about creating a new dialect, I guess, is one of the things I'm concerned about, right? Because then that's proliferation of yet another language related to FHIR and SQL. We already have several of them. You know, I've questioned many times whether CQL should even exist, let alone FHIR and now this.
I got you. So from my point of view, it is not dialect. It's a common denominator, what we have in databases now. So we are kind of reducing features, not adding. So we are not inventing no new semantic structure, no new behavior. It's trying to see the databases, what all of them have, like unnest. Yes, most of them have unnesting. We just make this like common syntax for all of them with translation. If they have accessing elements, we have very, very simple pass expression. All of them have some work with the datetime. So we provide some datetime functions. So it's kind of, we are trying to find the less, but we're not going to create more stuff. Yeah.
I wonder.
I understand your trauma after SQL. Yeah.
Well, that's what I'm getting at, right? Like, I'm just trying to think. The two questions that I have is there prior art in the HL7 community that we could use? And if not, is there prior art beyond this project that has already attempted to solve this problem that we could leverage, right? Because this seems like a problem that is not unique to what we're doing at all, right? We are trying to invent a way to query multiple database technologies. And if you take FHIR out of it and just replace that with any arbitrary database schema, everybody who's trying to do that will have the same problem. Right? They want to use Duck, they want to use Postgres, they want to use SQL, they want to use Oracle, they want to use all these different things. How do they write queries that work across all of them? I mean, this is a problem that's been around for decades, right? Is there a modern way to solve the dot delimited stuff? Is anyone working on this? And if so, can we leverage it? I don't know. I haven't done research.
So I've seen few SQL engines which are trying to. It's the specific technologies. Yes, like I forgot. Not drill. I think yes. So Apache drill. Its ability to provide some SQL which works with all databases, but it's much more complicated than this macro syntax. So that's so ability to create kind of like common SQL on top of existing technologies just doesn't work. Because every technology, every database add the new functions, add the new features every year, and you could not. So what I've seen from DBT, that the simple macro system, like they just using this Python templating language, and that work in most of cases. Like if you quite accurate, and for that, for the SQL on FHIR, I would like to even have less. So no macro like if else. Just a very, very limited subset. If you go outside of this subset, you're becoming technology specific. Yes, you can do this, but then you have to provide all popular implementations for that translation or something like this.
Also wondering, the other place my brain is going on this is I'm trying to think, should we use a FHIR resource to represent the query and break it into some type of structured document, like, for example, the way Elm works in CQL. Elm is not a FHIR resource, though I guess it could be. as opposed to just using a purely text-based approach, should we structure these things? Because I feel like processing a structured document might be easier, especially as this becomes more complicated. I'm just brainstorming here. I don't know what the right answer is.
Yeah, that could be very opinionated. So potentially we can invent some data representation of SQL ISTs, but again, so then we can find ourselves fighting with some technology.
Years ago, I worked at a company that sold a CMS, and it worked on multiple databases.
Yeah.
And one of the things that we did is that we had this logical object called a query that did this type of thing. It broke out the various pieces that we cared about, the columns, the where statements, and all that. It was a logical model on top of common database issues, and then we had a layer that translated it. And this is kind of the same thing. The syntax is currently, as you're proposing, is text macros, right? Is there a better way or a different way that would be preferable for some reason? And if so, what are the pros and cons? That's where my head is going.
Yeah, I'm as a opinionated closure guy, so can show you the better way, but not sure that everybody will agree to use it. So,
well,
yeah, if you
honestly, Nikolai, you're a lot smarter than I am, and I have a hard time with closure. It's like, you know, my little tiny pea brain.
Yeah.
So look, Evan, I
understand
feel the same
closure
way,
easily.
but you and I, Evan, would not have a hard time implementing support for the macros that Nikolai has shown so far.
No.
Like if it
Probably
really
not,
is,
unless it gets more complicated, which it could.
yeah, that's always the risk. But compared to inventing a new intermediate model for a query AST and then mapping everything into that, and from that to multiple databases, like if the set of macros we need is small, this is appealing.
Agree. I mean, it's part of my criticism of FHIR in general would be that it's sometimes too academic and too structured, right? So
Yes.
I don't want to proliferate that problem either, right? Not everything needs to be, you know, defined 6 ways to Sunday in a very formal spec, because then it makes it harder to change as well and all that. So
Mhm.
Do you think it would help to collect some practical use cases? You know, because I'm just trying to imagine what this looks like in a stack. You have a health app, you have DuckDB, you have all your data in there, and you want to make a query. You know, where do you put this macro thing? In a text file? And you have some kind of API, a Java API that you say, oh, here's your CQL, and I'm targeting this DB, and it transforms into this query, and then I put that in my query engine. You know, are you going to write a health app that runs over multiple DBs? You know, are we trying to write this macro language where we're giving this out to different people who are all going to be running this on different machines? Do we want this to be run in like whatever it's called, one of those UIs that automatically generate CQL, a BI tool? Like, I'm just trying to understand where this code's actually going to be typed, and how it's going to be used.
This code may be run as a middleware. So you're sending the SQL query to the backend, some service, which do translation, and after that insert the SQL, translated SQL. Yes. So or it can be
line.
Yeah.
But what if what if you're trying to build an app, right? I mean, most people don't write CQL on command lines. I mean, some people do, but is that the only use case?
Again, so from my point of view, this piece of code is going to be very simple. So it can be embedded anywhere. So it's like handlebars minus, yes, or Mustache templating engine minus. So it should be, you should be able to implement it with a 1 page of code. So you're just walking through this, looking for the special characters. Everything inside is a very simple function call. So you implement like tens of function call, like age, and nest, and something like this for your specific technology, and that's all. So you can serve this translator as a part of your solution. And we're gonna have kind of support. So the reference implementation for the popular databases like Postgres, Parquet, I know Spark SQL, BigQuery. So people will be able to look into the implementation and implement the same. So this stuff can be implemented in JavaScript, even on the client side, on the user interface. So you can translate this query. Eventually, if everybody like it, so we can create the operation like FHIR operation run SQL, which is maybe past this SQL, translate it and execute, or as well the part of the prototype that I can on this page, you can see how it's translated. So, and we can kind of create it without executor, just simple translator. So everybody can, and test cases so the people can test how it works. So from my point of view, it should be very simple, and we're going to keep it very simple, but it may solve. So if we carefully take this function, so the general idea, yeah, you have a function call. Here is a FHIR pass expression, which is translated to specific. This is a H function, which is getting FHIR pass expression. And that's it, like a nesting. And I can imagine that we only support like dozen of such functions, which are normalized, and that's it. So, and we should stop.
So even something simple like, having validation as you're typing, if you're in a SQL editor and you forget your AS and you put just A, right? It's going to validate. How are you going to validate these macros? You have to create a new validator. So that means you need kind of a GUI with that does the validation and understands how to validate the CQ on the macro stuff. I'm just wondering about
people living for years without validating SQL. So I don't think it's a huge problem. Yeah. So for example, yeah, we can build some parsers which are trying to, I don't know, we can take like some SQL parser extended with such stuff and write some validator. But I don't, again, so you're not going to write the program with this macro system. It should be very simple and very straightforward. And let's say in DBT world, simple Jinja, yeah, or how it's called, templating engine, which is just string templating engine, works well. Yeah, so people maybe sometimes can make mistakes, but it still works, yes. A lot of templating in Go ecosystem, which is as well, is not validated and blah, blah, blah. So somebody can develop the tooling for that, yeah. So for example, so what I did, so I did even syntax highlight for that, yeah. So it's not too hard, potentially like leaned on some very simple errors, like validating what's inside. Yeah, because we're going to keep it very simple. So if it's FHIR pass expression, it's quite easy validated. Only dots, names, and indexes are allowed. So you can run through the validation. So somebody can write this tooling and open source it.
So Nikolai, I'm wondering if you can help me understand some of the assumptions in the demo that you showed.
Yeah.
Let me see what I think we saw, which was a couple of different databases querying against the same structured schema representation expressed in Parquet.
Yeah.
And so any database that can sort of support Parquet structs and data types would be a potential target.
Yeah.
Early on in the project, we also talked a little bit about JSON structures directly and databases that can support those. Are you thinking about how to unify those two worlds, or saying that's a major fork in the road? If you're writing a query like this, we're already down the Parquet fork, and maybe there's also tools for the JSON branch of the fork, but it's a different set of tools. I just want to understand how you're thinking about that.
Yeah, so I'm trying to make both. So here we have Postgres, which is binary JSON, and DuckDB, which is a Parquet. Yes.
Okay.
And you can see that I can translate the same query to the binary JSON. As well, I can translate the same query to the Parquet. So my assumption that this row will be filled with a, I don't know, BigQuery and other stuff, because I do not see any problem for the basic queries to work. And from my point of view, the columnar structured data, it's a subset of JSON. And we can try to keep the JSON to break the schema databases as less as possible. So yeah, you can think it like a dynamic typing and static typing. So, and here kind of dynamic typing is superset, but we will try to limit ourselves in dynamic typing to still have one-to-one with the schema world.
So if I understand this, you're saying just from this perspective, static typing is a subset of dynamic typing. If you could handle dynamic, you could handle static, and the static is a special case. But in terms of the actual data types, am I right in thinking that Parquet actually has a broader array of primitive data types than JSON does?
It has, yeah. So potentially it has datetime and other stuff. So it has what's called logical data types. Yes.
Okay.
And that could be the optimization. Yeah. So we can work on this. Probably most of this can be hidden behind the functions. Like if you're using the datetime functions and other stuff, so it will be hidden from the people, because in Postgres, yeah, you see when you're doing Postgres, let's run this. So we're getting string and coercing it to the timestamp. Yes.
Yep.
But potentially in DuckDB, if the Parquet would be stored as a timestamp, I don't need this translation. So for now, it's the same like string coercion. But in the future, if you have more precise Parquet schema, so this can be skipped.
Cool. Okay, that's a great example. And in terms of the actual layout of like bytes on disk, that does have implications, right? Like if this was a more specific data type, it might have a smaller binary representation or something.
Yeah, yeah, and if you keep the data as an int, like integer, like the Parquet do, so that gonna be more efficient. Yeah, definitely more efficient than, or if you have enums in BigQuery so as well, so it's gonna be less data, faster lookups. But we should be able to translate JSON representation to the schema representation.
Yep.
That's what we can try to keep as much as possible. So if you have a JSON representation FHIR in SQL on FHIR format, and you have a schema, you can quickly translate, load data to the schema, to the Parquet schema, or to the, I forgot the name of the format for the BigQuery, but yeah, something like this. And looks like everything, yeah, the basic scenario is gonna work. So that's my feeling now. I will share the samples and this demo, so everybody will be able to play. And for example, here, yes, so we are building the flattened representation of the patient, and the view can use this query as a definition. And then the most of SQL databases will be able to work with that.
One thing I'll caution you about, Nikolai, with the age macro you created.
Yeah.
There's a tendency among other HL7 projects to make too many things, keywords and operators that should probably just be compositions from other simpler units. We got to be careful about how many of those we create, and and all of that, because that could get like in this case, you're doing a date diff.
Yeah.
And it looks like it's the same in Postgres versus DuckDB, right?
It is different functions, but
okay, it's different functions. Okay,
it's an age function.
Yeah. So we have to kind of figure out. I have no idea what the right answer is yet. I think we're only going to figure this out once we actually start trying to do things for real. Where there are very clear differences in different databases where they have these built-in functions and it provides significant value, then they have to make the cut. But I think we should be careful with those, right?
Yeah, we should be careful. Another problem which I see, that the FHIR potentially supports strings which could not be read by databases as timestamp, because in FHIR you can write just year, yes, or something like this, or partial.
Oh yeah, that's a big issue. Yes.
That can be solved on the translation layer potentially, so we can kind of add additional information during the translation, like transforming. So making them like more compatible with the database, because most of databases understand like year, months, day, year, month, day, like hours and minutes. So that could be the subject of the translator and the SQL on FHIR representation. And after that, I think ANSI SQL datetime functions would be the base for that.
One of the first use case problems that I'm going to attempt to solve with this model is multi-precision, I guess, highly precise variable precision dates, I guess, maybe, right? Because it's not just that FHIR only represents things as you know, an age, or let's say a date of service being 1980, right? When you go to do quality measurement on that, it deeply matters whether the date was expressed as 1980 or January of 1980 or January 1st of 1980. Those three things have distinctly different semantic meanings. And so if we don't have a way of knowing that this FHIR value is only specified in year precision, most quality measurement will not be possible. So that is absolutely a top level concern. It's one of the things I'm going to try.
Nice if you would create a discussion with these requirements, because that may help us to create.
So, yeah, I wrote up a bunch of kind of just thoughts about quality measurement in a use case discussion, and the date precision thing is something I brought up because it's one of the most obvious and quickly revealing issues. So I've started writing a very prototypical and non-sophisticated CQL to SQL conversion utility using these concepts. I used your Parquet files and all that. And, you know, I wrote a query that checks that you're over a certain age, you know, born after 1980, January 1st, right? But the next step from that is, okay, well, if I write the CQL to just say you're born after 1980, how do I handle that, right? And I think I'm going to have to use this meta query concept because DuckDB is going to do it differently than Postgres and everything else, right? So I can my options really are, I can either create views that somehow expose dates with parts so that I can query on them individually, or I have to write meta queries so that I can take advantage of the database specific precision extraction functions that they all have. So I don't know which is better, but I can experiment and see what they look like. But that's my next contribution that I'm going to try to make and work on.
I just had a quick question. I missed the first part. Are you proposing this proprietary DSL as part of the standard here for creating in your demo? Is that what's on the table?
Okay, it's a very simple macro language. It's not DSL. And it will have
a proprietary simple micro language.
It will have open source reference implementation in multiple languages, and you can contribute it. It's gonna be just one page of code. So it's gonna be very simple, just very simple translation.
So is it a combination? Are you gonna create a grammar? Is it a combination of like FHIR?
It's not even grammar, so it should be much simpler than grammar. So you just scanning string for specific symbols and splitting strings should be enough to implement this macro system in any language of your choice.
Right. Well, you can make a simple grammar too. Doesn't have to be.
We can make the grammar, but or somebody else can do the grammar for that as well. So this grammar should be embedded into SQL grammar if you really want to do this. That's what we discussed. So if you want, you can take Antler SQL grammar and embed this grammar. But it's going to be very simple. It just normalize the path access to element, nesting, and few functions like age and what we discussed. So just those in a function which are useful and can be expressed in most of databases. So that's all. It doesn't. It shouldn't have any other extra logic. Just few functions, path expression,
and this is an attempt to normalize the query across different engines.
That's attempt to write one query and run in different engines which support nested data structures. Yeah.
Yeah. So I have maybe a bit another idea about this kind of standardization layer. So yeah, I'm mostly doing software development in Python, and I'm not writing SQL as strings. It's like, I don't know, I feel like I get back in 10 years and see this SQL strings. I'm using SQL Alchemy, and it's already provides this abstraction on top of database engine and code that I'm writing Python. And if I write these queries in SQL Alchemy, it will translate based on the dialect to write SQL to query DuckDB or Postgres or whatever. So I think maybe we can provide some kind of recommendation on how it could used on
No, I don't believe you.
Actual software, development
Alchemy
level.
understand all of this stuff. So, but I think this type of macro can be even hidden, or maybe kind of the same stuff can be done with some ORMs, like.
I think
or
that
builders,
I don't need
builders.
macro. I need just some extension for SQL Alchemy, and it will work across multiple
And
databases.
you can do this, but this will not bring us to the portable queries, yes, because not everybody like typing stuff in Python. So you're lucky, some guys not, so they're using .NET or something like this.
There
So
is some,
the strings
I think,
look like
link queries, something
yeah,
like
but
this.
again, so they're different technologies. They still string builders because most of queries are strings to the database. So this is just the wrappers, and I can predict that. Yeah, I know the link queue can be extended, the alchemy can be extended to this stuff as well. If you're working with a specific database, you don't have to do this. Yes, we are talking about ability to distribute portable queries somehow, which you can run on, let's say, DuckDB or Spark SQL or Postgres or Oracle, and at least we will try. So my idea that at least we will try. If it works, that everybody life will be easier. If it's not, they will drop back to writing database specific SQL.
I can't imagine this is the first time that someone on the planet has attempted to abstract CQL across different engines. Is there any other projects or work out there to build on top of?
I don't know.
ORMs.
Every ORM in different languages trying to solve this problem. Yes,
Right. I mean, more like what you were saying at the kind of more core level. I don't want an ORM specific vendor solution.
Yeah,
I mean,
Apache Drill is trying to solve this by providing like a subset of SQL which you can run on different databases. But again, it's a specific technology. Yes, so Apache Drill is implemented in Java, so Ilya will miss this in Python because he could not run Apache Drill. So that's few orders of magnitude more complex system than simple macro language. It's a full-blown parser of SQL and even executor. Yes. So, and as I know that again, so DBT works quite well with a very simple templating. So, and people can distribute it. Again, in worst case, people can publish some queries with a specific implementation like .oracle.sql, .postgres.sql, .parquet.sql. Yes. So we can expect this stuff as well. So you can define view with a very technology specific definition. If you want to be portable, just provide definition for different technologies.
so a reference implementation is you could write your translator in Rust and then make a WebAssembly that could plug into any database engine, maybe.
But okay, so I see that the macro is the simplest way to do this. We can give up on trying to have portable queries, but why not to try? Yes. Maybe Ilya can play and try to build in this macro system or implement it in Alchemy. Yes. So then see it, or somebody will try to do it in LinQ. So, and
I just, even though you don't like the word grammar or DSL or whatever, I think it would be good to at least rough out the documentation of the formalities of your macro.
I was going to publish it this week, but I will publish the implementation and the short spec the next week. But it's very simple. The semantic is very simple.
The way I'm thinking about this, Nikolai, is in my head, this is how I'm mapping this out. To Brian's point, if we don't have at least very solid documentation, that would be the minimum. A grammar would be better, and ideally tests would be good. Because if we assume we're just going to have reference implementations with this, you're doing closure, so that's a JVM language, right? So great, that's Java. Well, I don't write any code in Java. I don't use JVMs. So in order for me to run this, I have to do it as an external process, or I have to figure out Java interop, or I can just implement it myself. To Josh's point, it's simple, right? This is a simple language, so I'm fine doing that, but I need to make sure that I'm doing it right, that it's going to match what you're doing so that it's universal. But I'm going to do this. I'm going to write these meta queries specifically in the context of creating views, because I want simple rectangular databases that ANSI SQL can work on, because that is what my customers will want. And then on top of that, when I create these views, what I'm going to try to do is create ANSI SQL compatible quality measurement views. And then I'm going to attempt to convert SQL to it. Yeah. And I can't wait to find out where all those pitfalls are going to be. And there's going to be lots of them. And there are going to be a lot of extreme complications. I'm already seeing, you know, the biggest issue I'm going to run into is dealing with functions. So my translator may need to translate into meta queries, which then get translated into actual queries as part of the stack, because, you know, even some, like you showed date diffing to calculate age, right? Well, calculating age is a fairly common practice in quality measurement. You always need to know how old somebody was when an event occurred. So if there is a native way to do that in Postgres and a native way to do that in DuckDB, so that I'm not writing these complex, just using basic SQL math, I would love to take advantage of those. And I think that's where the meta queries are exciting to me. I don't envision end users using them to actually write queries on a schema that they have, but I do envision us using it as part of the tool chain to get us from point A to point B, right?
Yeah. Evan, why do you always talk about quality measures?
Because that's all I care about. That's what I'm employed to care about at the moment.
You can translate his closure to F#, I think.
Yeah, I could, but I can't read closure because it's been 20 years since I've looked at Lisp, and it makes my head hurt. So
I'm actually interested in what you're saying as well, but I was gonna not do CQL. I was gonna look at ELM, and I think ELM.
Oh, right. Yeah, when I say CQL, I mean
okay.
Yeah. If you want to collaborate on that, we should. Yeah. If you're interested in this too, because this is going to be a long, cold journey.
I am, but I was taking an incremental approach, figuring this part out first before even.
Right. Exactly. I don't want to be kicking towards a moving field goal.
Yeah. So we can publish kind of test suite for that, because it's a string to string for specific technology. Let's say this is Postgres and bunch of pairs, how it should be translated. As well, the reference implementation. So everybody, again, so that's the reference implementation. So that if you take like this 3 function for DuckDB and that the generalized parser. So that's, I'm expecting it like 3 times bigger than right now. And so, and you should be able to implement it in every language. And we can publish the test suite for that, let's say for Postgres, for DuckDB. And so everybody can exercise their own parser, their own translator. Is it work correctly or not?
Yeah, I can take a stab at trying to create a second implementation of this.
Yeah.
So we can reach maturity level 2.
Okay, good.
Yeah, I'll try doing that within the next week or so. I might even write it in F# just for fun, because I like .NET. So
yeah, it could be even written in .NET, because again, so it should be as simple as implementing handlebars, even simpler.
Yeah.
So you're just scanning for the specific sequence. And
the reason I have concerns about using this meta language is just because I'm thinking about all the integrated tool sets people are using, right? Are we going to be able to do this in a Power BI world? And Power BI allows custom connectors. So do we have to implement the custom connector that does this translation, so that you're writing your Power BI in this meta language and it just works? Like, we could do that maybe. But every time you introduce one of these little like, oh yeah, it'll work, except it just introduces friction. So I'm trying to make sure that this is nice and smooth.
Yeah. And then we should understand, so the end users who is going to run some queries, yes. And these end users are not going to share their queries, so they may share them for the specific technology. Yes.
Could, right.
Yeah.
What if I say that I'm working on this project because I want to spin off a company that creates quality measurement dashboards that are portable on any database platform. I want those queries to work everywhere, right? Yeah. So.
But again, so that's a trade-off. So the end users, let's say they're working in Power BI, they can write just again to the Power BI database the specific queries. If you're expecting to share it between different implementation, so the first what you can do, like just write the specific queries for databases you want to support, or provide this macro, or maybe even run some util which will translate this macro into specific queries and provide both the
So what
macro query plus all the translations. So
the way I would recommend people would do that, if you're interested in writing Power BI for FHIR on SQL, which is going to be a big use case. That's all over the place right now, or Tableau, for example, and any of these analytics engines, right? What they want to be able to do is they want to be able to take the tools they're already using. So what we could do here is we can say, look, this is the standard schema. We're going to create views, and those views are going, the files, the SQL files that are going to generate those views are going to be platform specific. So what is your target DB? Is it a Postgres? Okay, here, run this Postgres view file. It'll create this schema, and then you can write Power BI on that schema, and you're golden, right? That's where I want to get.
Yeah.
That's where this is going to kick ass, because then people can say, like, this, take a look at this Microsoft stuff, because this Synapse analytics engine they've done, they created SQL schemas for all of the FHIR resources. What I would love for them to be able to do is say, you know, I don't want to ETL into a Synapse database. I want to ETL straight into AidBox, but I want to keep using all of the reports I wrote against my Synapse database. I just want to target my AidBox system. Yeah. If we have this view system where we can translate into the schema Microsoft already created, then you can supply that out of the box, right? That's a no-brainer. You just create the views for them and say the schema is called blah, blah, blah. You know, it's called Synapse. So now all the Synapse tables exist, but they're just views into your data. That would be super cool. So that's where my head goes when I talk about this stuff.
Let's try to build some POCs, working POCs, and then we will see how it works. So I'm pretty optimistic. So what I did this research through the different databases. So I'm pretty optimistic about this common subset of all databases which support nested data structures. And if we will be able to write portable queries on top of that, so we can flatten, when we flatten it, so we can support even more standard tooling, like all the Tableau, Power BI, and other stuff, and describe it somehow and deliver this definition of to the user.
Part of the problem is that a lot of the people who are going to be consuming this, right, they're going to be writing the SQL to create the reports. They're not as smart as us, right? They just know SQL and nothing else, right? So if you start shoving anything that's too complicated at them, they just won't be able to do it, right? We have a lot of people who know SQL and nothing else. So if you say, well, you just run this just run this tool, and their eyes will glaze over, right? So giving people options to make this simpler, that is going to be a huge win. People are going to love that. So that's
are you all going to New Orleans in May?
Yeah, I just booked it.
Yes, and we have a track. So
yeah, I'm probably going to hang out at this track. We can sit down and code and get some stuff done. I think that would be cool.
How about you, Brian?
Yeah.
Awesome. So we will have a very nice team.
Okay, I got to drop.
Join virtually.
Okay, guys.
Okay, I got to drop, but thanks. This was a great demo. Is this? I missed the beginning. Did you push this up to a GitHub?
I'm gonna publish it next week. So I locally. Get into this Java interop style with a Parquet. So, but I will publish the transformation and this macro translation. And everybody will be able to run it.
Yeah, we should have like a wiki or something where we can start documenting how the macro language works. So if we decide to, like, I might decide to invent a new macro if it's useful, then I can document how it's supposed to work.
Yeah, and for the next week, I will document this simple macro, the initial layout, so then we can discuss it later.
Great, thanks. Okay, talk to you guys next week.
Thank you. Bye-bye.